I'm Troy Topnick. I'm the Director of Product Management for Rancher Partners and Ecosystem. And that's not as important as some people I'm going to mention in a bit, but one of the things under my purview is a thing called Application Collection. Right now it's called Rancher Prime Application Collection. You may hear Pete tomorrow in a keynote call it SUSE Application Collection. That is intentional. And but everything you're going to see here is going to be as the UI is right now. And yeah, we're going to set it up a little bit about by talking about why we built this thing called Application Collection in really pedantic terms, because I think most people know the importance of security, but it kind of sets it up to talk about just how bad it is at the moment, like how bad the global situation and how hard it is to defend your software estate, your IT estate. We're going to talk about what trusted procurement means and what characteristics it has. Take a look at some rather severe instances of CVE impact, or more to the point, how you evaluate how much a particular CVE is going to impact you, or the lack of maintenance of a piece of software is going to impact you. And then we're going to take a look at how software evolves over time, especially in this cloud-native space, and how it changes and how you can track those changes. Throughout this, I'm going to demo Application Collection, and I'd invite you guys to, if you've got a browser, nobody's got a laptop up and say, I'm going to have to drive it all. I'll demo it as we go, and we'll see if it works, and I'll show you what I can show you. These people actually should take credit. I'm sort of a late arriver to Application Collection, which itself is very recent. It was only just released at KubeCon Paris, which is 3 months ago. And this team hasn't even been with SUSE all that long. This team is under the direction of Manuel Racina, is based in Seville, and they're amazing engineers, and they've done a tremendous amount of work, and I wanted to give them some props for that work. So there's been a few software supply chain talks today. It's a very, very popular topic. We talked earlier, like an hour ago, about what it means to make your own software supply chain secure and the processes by which you do that. This is coming at it from another angle. We're going to tell you how we have already done this at SUSE so that we can provide a good base to build your own software supply chain. This is something I discovered recently and added to the deck, the Canadian National Cyber Threat Assessment. Threat actors are attacking targets indirectly exploiting vulnerabilities in supply chain and internet infrastructure. So this, I would recommend reading this whole thing, even if you're not Canadian. But it does talk about how this expanded area of threat has come to include the tool chain that we use to build software. And we've had attacks on software in place that is running for years and years, but increasingly we're seeing that, especially with third-party code or third-party components of your code, libraries and such, any project that uses those is going to be vulnerable if there's vulnerabilities within them. So some more rather disturbing numbers. 2021 to 2022, supply chain attacks grew 742%. I mean, that's 2022. I wonder what happened in 2023. Oh, not only did it get worse, but the rate at which it got worse got worse. So this is, like I said, it's not the only place you're going to be attacked. It's not the only part of your threat surface, but it is definitely growing. And as we've heard in other talks, there are now state actors. There's tremendous. It's a lucrative, increasingly lucrative way to extort money. And there's lots of sneaky ways that we're finding to break into software and to break into supply chains. And these are the famous ones not all the same. So sunburst, I didn't recognize at first, but that's actually the SolarWinds exploit. Log4Shell is huge and everywhere. The XZ backdoor is a little bit different in how it was accomplished, but it was also a supply chain attack. Fortunately, caught relatively early, so it wasn't as widespread. But I found some shocking things about Log4Shell. 41% of organizations globally were hit by this. And the shocking thing is that people kept downloading vulnerable versions of Log4Shell and deploying them. And the statistic, 1/3 of all Log4j downloads ever are actually vulnerable. Now, they may have been remediated since, but that's rather a lot of vulnerable software out in the wild. So these are the ones we know about because they've been talked about a lot in the press. And our bosses say, what are you doing about this? There's tons that are maybe not as dangerous, but maybe just as dangerous, but unknown. So there's a lot of stuff out there that we got to pay attention to. And when these things hit the news, when these things blow up, governments take action, rapidly take action. How do governments rapidly take action? Well, the best way they can, by making legislation. Now, good SREs, good security people know how to react to vulnerabilities. Governments, just in the way they are, have to, their job is to write laws. So unfortunately, these laws, which we can see a lot of them there from the European Union and the US, I'll go read them all for you. I won't read them all, but you get the idea that just complying with the rules that are put in place to prevent further problems adds to the load and actually might slow down response to these threats. So it certainly takes away from the time that you have to respond to the threats, because now you have to do a number of reporting things. You have to report on breaches in a certain way. You have to attest that you have taken steps to prevent these breaches. There's a myriad regulations now in place. And it'd be nice to have some help with that. And there are some tools. We just saw an amazing demonstration of New Vector, which can produce some of these reports. But it should be, something should be doable to make your life easier, just in terms of where you get the software that you're going to deploy. So our solution at SUSE is application collection. It's trusted and audible. It's auditable. It's a place. It's not much of a departure from what SUSE has been doing for 30 years. A trusted, auditable source for software. Now, the difference here is that it's just software in a different packaging format with some orchestration behind it. It provides an evaluation of the impact of the vulnerabilities that you do discover or that are present. And it gives you a general overview of the health and safety of the software that you're using or the distribution that you're using. It's called Rancher Prime Application Collection. You may hear it referred to tomorrow as SUSE Application Collection. They are one and the same. Let's talk about, let me take a look at how much time we're going to have here. What do we mean by trusted software procurement? How many people here work directly in software development with development teams, like coding software? Oh, I see. Somebody there. I have found that teams, especially in larger organizations, are working on slightly different, even slightly different software projects. Unless there's a strong mandate to consolidate on one technology stack, will choose their preferred technology stack. This was one of the reasons behind the popularity of platform as a service, which I worked in for quite a while, to give developers the choice to be able to do this. Now, the downside of that is that what tends to happen is especially if there's a wide variety of technology choices to make, the central IT department of an organization won't be supplying that. The teams go on their own accord, source the open source software from wherever they get it independently. So what we ended up with is multiple sources for that software, whether they're different Helm repositories, and we're talking about container native workloads here. So Helm repositories or OCI container registries. This is a security risk because you don't sometimes know where that's coming from. Maybe we're placing our trust in somewhere we shouldn't. More often than not, software bill of materials is not available. And so when you do have to comply with those regulations we talked about earlier, it's hard to do. You can't really tell everything that went into that container. You can pick it apart. You could manually go through it, but then again, that's going to take a long time. So that's a problem. Transitive dependencies, by which I mean dependencies of dependencies, nested charts, and so forth. It magnifies the problem that's inherent in software development in anything that has dependencies, just by having multiple components. So because Helm charts, cloud-native applications have a lot of moving parts, you're going to have more transitive dependencies, and that increases your complexity and risk. Variability of configurations. There you will see a lot of different Helm charts for the same piece of software, and they're configured differently. And if you have one organization that is pulling from a couple of places, that can get confusing, and that can increase complexity, of course. And what we've seen a lot, especially, and one of the motivating factors for us to make application collection, is that we notice that base images are from everywhere. The promise of containers was that it shouldn't matter, that you can just grab whatever container image you want, and there'll be good handling of that. But in practice, it turns out that it's very, very hard to maintain software when you've got base container images that are all over the place in different versions. So our solution to this, a single trusted standard way to install open source applications. We update these continuously. Every time there's a change or a vulnerability, trustable, auditable, and compliant. So I wanted to show an example here with one of the first ones that I saw when I first opened application collection, which is Apache API 6. It's a great piece of software. It's a, what is it? It's a open source API gateway. And it's not a huge chart, but it does ship with 3 chart dependencies, so 3 subcharts within it. And making that up, we have 2 different vendors in that one chart. This is the upstream chart for this. So Bitnami is one, and API 7, based in China, is another. The images in the upstream chart, and I just checked the latest one last week. There's a Debian image in there with 2 critical and 24 high CVEs. That is in the most recent available. Another Debian image with 6 critical and 54 high CVEs. Another one from Bitnami, their etcd distribution that is in this chart has 2 critical and 36 high CVEs. And the last one is a BusyBox image, and that one was fine. But that's a lot of pain. So let's compare it to application collection. We've got a single trusted source. All of the base images here are coming from SUSE. They're all the most recent we can get of SLE micro, or sorry, the SLE base image. And yeah, let's have a look in. Here's there's a front page of application collection. Let's look at API 6. And let's look at this most recent one. no detected vulnerabilities. And we have a list of all the system packages in that base image, along with some OCI annotations. Software bill of materials in 2 formats, salsa provenance, all these are JSON files that are in a standard format that you can produce reports from. You can fetch all of this stuff via an API, a REST-based API, which is documented. And in addition, we actually run NuVector and Trivy on it to so you can see the reports that come in from there. And that's what's listed here. Just for belt and suspenders, we run an antivirus scan on it as well. So I'll walk through this. Let's just sort of walk through the slides of what I'm going to do, and then I'll do these things on Rancher Desktop, which I should also highlight here. I wouldn't have been able to do this demo if I hadn't had a nice local Kubernetes environment to work with. And this was the fastest way that I could get something that I knew would be reliable and working on at a conference. So I'd encourage you to check this out. That's what this little icon is running up here. And on this, I've actually run Rancher. And we can look at the apps that are running, what's installed. I'm getting sidetracked here because what I actually want to show is how to do it from the command line first. So first what I'm going to do is I'm going to log into the application collection. This is a good time to point out that all Rancher Prime customers have an entitlement for this. So it has to be manually enabled. So if you're a Rancher Prime customer, contact your AE and have them set you up with this. We are looking at the possibility of having a separate SKU for it so that this could be purchased separately. But right now, this is a value add for Rancher Prime customers. So you log in. You can browse this without logging in, but for this step, actually using it, you're going to need to authenticate. And so to authenticate, we create a token, and we get the token, and we can use that token to log into the Docker registry, the app collection Docker registry, which is, or use that same authentication with Helm to authenticate, because we're actually grabbing the Helm charts from an authenticated registry as well. And these examples here show you also how to create a Kubernetes secret that can then be used when you're deploying, so that Kubernetes has the pull secrets required to actually get the images. And then we'll install it. So I'm going to grab that if I can, and we can get started. Actually, I'm not going to grab that first. I'm going to grab, I think I just need the Helm one. And I'm going to actually do it in the shell, because that's something we all understand. We haven't always. Okay. Is that a good size for everyone? So we're going to log in, and you can quickly copy down my token there. I created that token. You can make multiple tokens, and you can rotate them. So there's a method there. So that is there, and then I think here I have the particular Helm command, and I'm going to install. Note the image pull secrets, referencing a secret called application collection. So let's use that. I think this is installing. What am I installing here? InfluxDB. Okay. Let's get the password. Come on. Bear with me a second here. Okay, I think that'll work. Just to prove that it's actually working here, I'm going to forward a port here. This Rancher Desktop makes it quite easy. And we'll send it to 8080. And we'll see if it works. Yay. There we go. And I got the copy paste wrong. Anyway, you can see InfluxDB is running. We won't see the pretty dashboard. So there you go. That's the install process. A couple things worth noting there is that you have to include the image pull secret. There's the app. Okay. So evaluating the impact of and I should go back to slideshow mode here. Let's just put ourselves in what's probably our own shoes here. A new CVE has just hit the papers, and our management is particularly concerned about it. They might not understand it very well, but they want to see some detailed reporting on what the risk is for our organization. They've asked for a CVE impact evaluation. Well, what would you do? We've seen just in the last session, you can do a fair amount with NuVector and provide that, but we can do this for you. So let's figure out how many nodes and different workloads are impacted. So the way we would do that in App Collection is to look at the artifacts section that we saw earlier. We would search for the particular CVE, and if I can remember that, 27281. We'll try that in a minute. And then we'll see what containers are affected and go and take a look at what the impact is. Let's try it. So we'll go in to artifacts, search for 2024, 27281. We'll search on the vulnerability. I got it wrong. What am I doing wrong, folks? Ah! Thank you. That was a test. There they are. I even said it wrong too. So let's say we've got FluentD here. Which version is that? 1.16.5, build 5.2. And there's the CVE. We can click on it and read more about it. And yeah, so let's now look at this and see if there's a version available that actually solves this. There's a comparator here. So we can actually compare that copy of FluentD against another. Let's pull one from 1.16 somewhere. And this is far too small for my eyes. What the most recent of the 1.16.5, that one. And there we've got a version that actually corrects this. And this would not have been available upstream. This was something that was corrected by application correction and application collection, and is superior to what is available upstream. Now, with this sort of information, we can sort of see the differences between the versions and revisions of the software, which we've just seen. And we can, over time, and remember, application collection is a very new piece of software. It's a very new service from SUSE, and it's going to get more feature-rich as we go. And it's going to do that because we've got a lot of data from all of these builds. You saw how many builds we were making in the artifacts section. And so we're going to be able to gradually make this richer. I'll get into some roadmappy things a little bit later, but in the context of cloud-native artifacts, version number, we were sort of separating the version number, which is the application number, with the revision number. What we're calling a revision number is a build number, basically, and that's how I matched the version, got a more recent build. And this is just showing us what we already did. We looked at FluentD. We got here from a different path, right? We looked at the CVE and we got to what we're going to do here with the compare versions. So we went into FluentD. we found the one that was affected by that that CVE in particular, and we fixed it. How are we doing? We got lots of time. Any questions so far? Anything? No? Okay. I'll just skip through this. Another place to get to that. Oh, that's it. Apps.rancher.io. I think we could talk a little bit more about where we could go from here. And I saved this for the end because I wasn't sure we wanted to get into it, but since I blazed through that quicker than I thought. It's really good to know how, in your Ouroboros talk an hour ago, we talked about how the practices of that were sort of detailed in the Phoenix project and systems thinking produce good, secure software, and we can actually examine the history over the development of the software over time to see how well it stacks up against these practices and how reliable it will be in the future. So most of the risk assessments that are done with tools will just look at the number of CVEs and say this is a high number of CVEs bad, low number of CVEs good, but there are more things that we could do to make this better. So there's other reasons why software can be, stale or not optimal, and we want to have as much visibility into that as possible. And there's various ways that we can look at it. This is where I stole from your slides. So a wider representation is useful, and these are the accelerate metrics that you can sort of work back from these as ways you can look at the software to see if these are being met from the other side. So these are the accelerate 4 key metrics are designed to be things that they're things that your team can adopt to improve their software development life cycle and practices. But we can see if that's been done. So not just how many vulnerabilities are present at any given point in time, but how many have appeared over time and how quickly those have been remediated. Because we're building things so often, we will be able to get some metrics on how quickly a particular upstream piece of software remediates its problems, and the severity of the problems over time, how many severe problems that particular software has had, and also just the cadence. I want to point out that application collection is different than the Rancher partner catalog, which you see in the Rancher UI, which I sort of glossed over earlier. We would sometimes see partner charts in there that would be revised once a year. And that's absolutely not good enough. Even if it were a really simple app and maybe they didn't have a lot of CVEs, this one in particular did, that it's not good that, it might indicate that the software is not being properly maintained. So we would expect to see that more frequent and more regular software releases is a good thing. The base OS freshness also, even if it doesn't have a lot of packages installed in that base image, you can sometimes tell. Generally, it will accumulate CVEs over time if it's not refreshed. But it could be just another indication that nobody cares about that particular part, that the maintainer is not on it. We update it in application collection, but this is a good measure of how often people are paying attention to that and other not necessarily vulnerabilities, but dependencies. And when we're evaluating software for do we want to deploy it on our estate, we want to know how complex it is, because the more complex the application is, the larger the threat surface on it, generally speaking, and also the more difficult it can be to debug. Now, we heard today, we've got Stack State coming on board, and we'll have some tools that'll make that easier. And looking forward to using those. But it's something we want to know. And this is may or may not surface in the product. We were thinking about ways we could show just get an intuitive idea of how software is developing over time, comparing two different software packages. So we came up with this multi-dimensional chart, and it's all in a very light gray. So vulnerabilities, release cadence, complexity, and the OS. So you can compare over time, and you can add axes as we start to measure more metrics and start to have more points of comparison between different applications. So that's it says coming soon to application collection. I'm not entirely sure it's going to come out like that. We're still thinking about it, but yeah, I want to thank you for coming.